Hello. In this video, we're going to take a little break from Lewis structures. Now we've talked about the basic ideas of bonds forming between atoms to form molecules. We're going to talk a little bit about that these bonds sort of form a spectrum, a continuum from purely shared electrons and covalent bonds all the way to ionic bonds. And what we're going to talk about today is sort of in this video is in the middle, which are what we call polar covalent bonds. So let's start by looking at a couple of examples of molecules. Let's think about chlorine. So we can draw the Lewis structure for chlorine. If we count up the number of atoms, there's 7 electrons per chlorine atom. So we get a total of 14. And we'll draw a bond between them. And we'll end up with 3 lone pairs on each chlorine. And this is the Lewis structure. So this is the molecule Cl2, chlorine gas. Now, our 2 chlorine atoms both like electrons the same amount. They both prefer to have the same amount of electrons. So this is a purely covalent bond because the 2 atoms are exactly the same. So these electrons in the middle here, I'll use a different color, these electrons here are completely equally shared. So there's no preference for either chlorine to have more of the electrons to itself. On the other hand, if we look at something like HCl, we'll draw its Lewis structure. It's very similar except for that hydrogen only wants 2 electrons. But we know from experimental evidence, and we'll talk a little bit more about how we know this, that chlorine prefers to have more electrons. Chlorine has a stronger pull on the electrons. And so even though this forms a covalent bond where the electrons are shared, they're not shared equally. We get more electrons towards the chlorine side. And this is what we call a polar covalent bond. Polar meaning the fact that it has what we call a dipole, meaning there's a little bit of a positive charge here and a little bit of a negative charge here. Not so much as an ionic compound, something like NaCl, which we don't even draw with any shared electrons. Here, these are completely positive and negative charges. And if we were to draw the Lewis structure, chlorine would have all the electrons, and sodium would have no valence electrons because it would have given up an electron. And this isn't really an accurate way to think about it because it's a big crystal anyway. But here, chlorine has pulled on the electron so hard that it has taken the electron from sodium. HCl is in between this. This is this polar covalent bond. And there's a couple ways we represent this. And we can also, think about, when is this going to happen, when is it not going to happen. So one way we represent the chlorine having a small negative charge is that we write a little Greek letter delta and put a negative. And this is just to indicate that it's a partial charge. And we do a positive on this side. So these represent partial charges. So rather than a full positive or negative charge, which we would have with the with an ionic compound like sodium chloride here, down here, instead we only get a partial negative charge and a partial positive charge. Another way we can represent this, and you'll sometimes see this as well, is to draw an arrow pointing towards the negative side. So this will be the negative side that's implied, and then the plus is sort of embedded in the other side of this arrow. So this is the symbol that's used, this arrow with a plus sign sort of embedded on the one side of it. So the arrow points towards the negative side and it points from the positive side. And again, this is indicating a partial positive and partial negative charge, not a complete an electron transfer completely, but in between. We can also look at this sort of graphically using a figure from your textbook that looks at this and see that this exists on a continuum, right? So these are our 3 molecules we looked at already, 3 compounds. In chlorine, the colors here, if the colors are all about the same, that means the electrons are spread evenly across the molecule. In HCl, we get a little bit of a positive, electron poor on the hydrogen side, and a little bit more electron rich in the oranges here on the chlorine side. Whereas in sodium chloride, where there's true transfer in electron, Sodium has become very electron poor because it's a completely positive charge, and chlorine has gotten this extra electron, so it's very electron rich. So that's another way of looking at this. Okay, so that is what we're talking about when we're talking about polar covalent bonds. In the next video, we'll talk about how do we know if a particular bond is going to be polar. If it is a covalent bond, if we're looking at a molecular compound, how would we know if the bond is polar or if it's a very equally shared? And we'll be looking at a scale called electronegativity to understand that.